In our last video in the section on solving rational equations, I wanted to take a look at a more complicated rational equation where I have multiple terms and all of a sudden instead of just having some x's, I have x squared within my large, nasty looking equation. Now as I try to solve this rational equation, again I notice that this isn't a proportion because there's two terms on the right side. Even though it's just a plus one, that still ruins our ability to use cross products to solve this. So what we need to do is get rid of all the denominators by multiplying everything by a least common denominator. Now before we find that least common denominator, I would encourage you to factor any sort of quadratic expression that I have. So x squared minus 4, I'll quickly factor using the difference of squares pattern into x plus 2 times x minus 2. So now looking at the three fractions that we have, one fraction has a denominator of x minus 2. The second has x plus 2 times x minus 2. And the third fraction just has a denominator of 1. So when we find the least common denominator of all three of these, I know that I will have to include an x minus 2. I know that I'll have to include an x plus 2. And this second x minus 2 is already covered by this denominator, so I don't need to repeat it. So these two factors are going to make up my least common denominator. So we're now going to multiply the entire equation by that least common denominator. Now multiplying it by the first expression here, the x minus 2's will cancel. And again, I'll write this as being these two over 1 just to remind you that we are multiplying numerator times numerator and denominator times denominator. So x minus 2's will cancel. That will leave me with the x plus 2 having to be multiplied by 3x minus 2, which is in the numerator right there. Equals. Now on the right side, when I multiply this least common denominator by the equation here, both the x plus 2 and the x minus 2's will cancel, which leaves me with just 6, and that's it. Now the third and final expression excuse me, is a 1. There are no denominators that I need to cancel. So that's going to be a matter of simply taking 1 times both of these expressions, x plus 2 times x minus 2. The equation we now have in red is a little easier to look at because there are no denominators, but it's not quite as easy as the linear equations that we had to solve in previous videos and previous examples. Now, in order to solve for x with the equation that we have left, I'm going to get rid of the parentheses by using FOIL for both sides. So on the left side, I FOIL this expression, which gives me 3x squared minus 2x plus 6x will give me plus 4x as my middle term. And finally, minus 4 as the final term. On the right side, I still have the 6 plus, when I FOIL these two expressions together, I have x squared minus 2x plus 2x. Those cancel, I'll have 0 in the middle, and finally negative 4 at the end. Looking at the equation that we have in blue now, there's no more parentheses, which is good, but if you notice, we've got an x squared, and not just on the right side, but also on the left side as well. So instead of having a linear equation, when I have x squared as one of the terms, this is now a quadratic equation. Luckily, we know how to solve quadratic equations because we spent quite a bit of time practicing it earlier in the year. In order to solve a quadratic equation like the one that we have left, I probably would like to set my equation equal to 0. Now to do that, I'm going to subtract x squared from both sides. I'll subtract the 6 and add the 4 both at the same time here. So minus 6 and plus 4, I'll kind of stack them on top of each other. I'm subtracting the x squared from the squared term that's over here. So it leaves me with 0 on the right side. On the left side, 3x squared minus x squared is 2x squared. Plus the 4x that's still there. Negative 4 minus 6 plus 4 is going to be negative 6. So we have a quadratic equation that's set equal to 0. 2x squared plus 4x minus 6 equals 0. And we know a lot of ways to go about solving that quadratic equation, including graphing or maybe using the quadratic formula. I'm going to choose to use factoring in this case because this one I believe can be easily factored and solved without the use of the quadratic formula or even a calculator for that matter. So as I look at the three expressions, I notice a greatest common factor of 2, which I can factor out of each term. This leaves me with the trinomial x squared plus 2x minus 3, which I can factor further into the binomial factors, x plus 3 and x minus 1. I factor this way because I know that the first term has to be x in order to come up with x squared as a product, and then I need factors of -3 that add up to +2 for the two second terms. I still have a 2 there, but that doesn't really change my answer a whole lot because at this point, I now have a product, one thing times another, and it equals 0. I then use the zero product property to decide that, well, if something plugged in here makes everything equal 0, that something must be -3. -3 plus 3 is 0 times, who cares what the rest of it is, it's going to be 0. And my other answer is going to be +1. I'd say 1 minus 1, that's 0 times, who cares what the rest is, it's going to be 0. Now, in this case, I have two answers, which will happen on occasion. But anytime there's two answers, I should be careful to check for extraneous solutions. When you're extraneous, you think extra. It means we did all the algebra correct, but just because of the odd way in which rational equations sometimes work, maybe if I plug these numbers in the original equation, they don't actually work out. So we have -3 and 1 as our two answers. Let's go back and check them out. Now, when I plug them into my original equation, the biggest thing that you need to look out for with extraneous solutions is if, when you plug a number in for x, it forces you to divide by 0. That'd be no good. So I had -3. If I plug it in here, am I going to be safe? I think so. If I plug -3 in this denominator, will I be safe? Yes, I will. Same thing if I plug in +1 here or +1 there. I'm not going to have to divide by 0. So I'm going to guess that those two numbers are going to be just fine.